Okay, this is the first lesson of chapter 4. This is inverses of functions. So right here we have two functions. We have the cube root of x plus 1, and then we have subtracting 1 and cubing. So it's kind of obvious that they're opposites of each other, but will they undo each other? So if I put 8 into my first function, I cube root 8, I add 1, which is 2 plus 1, and I get 3. So that means I put an 8, and I got 3. Okay. Well, then I put into my g function 3. I put in 3, I get 2. 2 cubed is 8. I put in 3 and I got 8. So the big idea of inverse functions is that the inverse function undoes whatever the original function did. So that's our big idea here, is that they're going to undo the original action. Well, inverses of relations, which are functions sometimes, if we're given the ordered pair xy, then the inverse will be yx. So the domain and range will flip-flop. So example 2 says, find the inverse of each relation. State whether the relation is a function, and then state if its inverse is a function. So if we look here, 1 goes to 2, 4 goes to -2, and 3 goes to 2. That's a function. 2 goes to 1, -2 goes to 4, and then you're telling me 2 goes to 3. That's not a function. You can't assign x to 2 different y values. If I were to input that in a computer, it would error. I mean, it's okay though. It just means it's not a function. Here, the original is a function, and its inverse is a function. So they're both functions. That's a special name. That's called a one-to-one function. You'll learn more about those as you go into higher math courses. We really like one-to-one functions. Okay. Example 3. It says to find an equation for the inverse of a function. So when you're not given just coordinates or discrete functions, you're given continuous functions that are long graphs on a chart. You're saying, I take x, I multiply it by 4, and I subtract 5. How could I undo that? Well, you could think logically about it and say, the last action I had was subtracting 5. So the first action I'll have is to add 5. So add 5 to both sides, and then the first action was multiplying by 4, so divide by 4. That's just thinking about it, and that's totally fine. But if you can't think about it like that, we said the domain and range flip on x and y. So that's what I'm going to do. I'm going to flip my x and y for the inverse function. And I want a y equals function. So now I have to remove 5 and remove 4. Inverses are undoing. Solving is undoing. So in order to get y by itself, we have to solve for y or undo what we did. So we have to undo subtracting 5. We add it. We have to undo multiplying 4. So we divide it. We can't write it as y equals because it was really y equals to begin with. So we write it as y inverse. You can always pause and go back if that was too much or too quick. So once again, we have a function here. We're going to multiply by 2, add 3, divide by 5. So to get rid of dividing by 5, we multiply by 5. To get rid of adding 3, we subtract 3. And since this was first, then lastly, we divide by 2. You can do this if you want, but if you can't think of it like that, then switch your x and y and solve for y. Get rid of the 5, get rid of the 3, and get rid of the 2. How do we get rid of the 5? We multiply by 5. How do we get rid of the 3? We subtract 3. How do we get rid of the 2? Divide by 2. We can't write it as y inverse. And it looks like it's saying it's to the negative first, but math's kind of like English where you see the same words, but they have different meanings. So here, it's y inverse. It's not to the negative first. All right, so this is talking about an equation, how you'd write the inverse, but let's talk about their graphs now. We always talk about algebraically and graphically. So now we're on to the graphs. So we're going to graph x squared. And if you didn't remember what the shape of this was like or where the vertex was, you can graph any function using a table of values. I always suggest using positives and negatives to see both sides of the graph because it's usually around here for this class anyway. So x squared, you're going to substitute in 0, 1, 2, -1, -2. And that seems to be sufficient. Now, with inverses, the graph should somewhat look like the function of the original. So the inverse of squaring is square rooting. So if I take the square root of 0, I get 0. If I take the square root of 1, I get 1. I don't like 2. I don't like 3. So I'm going to go to 4. Square root of 4 is 2. And we draw half of a parabola. That would just be the square root of x. But really, its inverse is the positive and negative square root of x. So the negative square root of x would also be, when I got 1, the opposite of that would be -1. And when I got 0, well, 0, opposite of 2 would be -2. Yeah, the square root of 4 is 2, or technically -2 if you were solving. So the parabola is on its side. They are reflections of one another on this y equals x line. When I say y equals x, it's kind of like an axis. It is an axis. So wherever there's an x, 1, 1, 2, 2, 3, 3, and so on, the reflections on this axis here. Okay? All right. So it says we can conclude that the graphs of f and f1 are reflections of one another on the y equals x line. Recall a graph as a function if and only if every vertical line that intersects the graph does not intersect at more than one point. So we've talked about the horizontal line, or I'm sorry, we talked about the vertical line test. So if I look at this function here is x squared, or it's not x squared, it has the shape of x squared, I should say. If you complete the vertical line test, it's a function. If you complete the vertical line test here, it's a function. If you complete now, we're going to introduce the horizontal line test. If I draw a horizontal line, it crosses at more than one point. So its inverse is a function, or is not a function. So without having to redraw this graph, like here, so without having to draw this and then draw this, we can just look at this and say, oh, I know its inverse isn't going to be a function. I can look at this and say, it's a function, but its inverse, oh, its inverse is also a function. So this is a one-to-one function. All right, and I just put this here because its inverse function would have that same shape as plus or minus square root of x. All right, so we talked about the graphs, we talked about the equations, we talked about coordinates. Now we're going to prove that two equations are functions. So when it says show that they're inverses of each other, this is not showing they're inverses of each other. This is showing that you're trying to find the inverse. It's not proving or showing that they actually are. So how do you prove it? Well, if they technically undo each other, you're going to use composition of functions, meaning you're going to put one function inside of the other, and hopefully they'll just undo each other. So if I take this entire function and I put it inside x like this, well, 4 times a fourth is 1. 4 times 3/4 is 12/4. So it's going to be 3 minus 3. Oh, it cancels out and we just get x. Well, you have to do that for the other function too. It just worked one way. It has to work the other way too. So if I look at g of x and I take this function here and I put it in where x is, does a fourth of this plus 3/4 just give me x? So does a fourth of 4/3, or 4x minus 3 plus 3/4, which is going to be 4/4 x minus 3/4 plus 3/4. Well, that's just going to give me 1x. So since you get x from both, They are, in fact, inverses of each other. That's proving it. Okay, so there's going to be homework problems just like this. There's going to be homework problems that are just like this. There's only one graphing. It's super easy. They give you the coordinates, but I have all the homework worked out for you. Okay, it's already done. You just have to upload it, or I'm sorry, download it, and you'll take a homework quiz in a few weeks. Always feel free to email to ask questions.